So hi friends, I myself is Harivatsa, studying at Madras Institute of Technology and University. I am gonna explain what is CNC lathe machines in this video lecture with some basics. So let's start the video. So before explaining what is a CNC lathe machine, I will explain what is a CNC machine. So CNC is known as computer numerical control. Conventionally, an operator decides and adjusts various machine parameters like feed, depth of cut, etc. depending on the type of job and controls its line movement by hand manually. So in a CNC machine, functions and slide movements are controlled by motors using computer programs. So what are the types of CNC machine? There are many different types of CNC machine used in industry. So mills and machining centers, lathes and turning centers, drilling machines, medium sinker and wire cut machines, flame and laser cutting machines, water jet profilers, etc. based on the machining we need. So types of CNC machine control units. The machine control units gonna give the signal output to the machine by what the input we given. So there are different types of CNC machine control units. These are Fanuc control, Siemens, GSK, Mech3, etc. So program input. These are the input we given to the machine control unit. So there are different ways of data input, like manual data input, the program preparation with CAD or CAM, program data transfer from PC to CNC machine, or program data transfer from PC to DNC operations. So this picture will visually represent the operational features of a CNC machine, like how a CNC program is generated and how it is converted and how the signal is given to the machine and how the machining takes place on the workpiece. It can be explained by these visual representations of the pictures. So, for CNC, machine control unit decides the cutting speed, feed, depth of cut, tool selection, pull out on or off, and tool pots. So these MCU issues commands in form of numerical data to motors that position slides and tool movements accordingly. So overview of NC. A numerical control or NC. So a system controls many machine functions and movements which are traditionally performed by skilled machinists. Numerical control developed out of the need to meet the requirements of high production rates, uniformity and consistent part quality. Program instructions are converted into output signals which in turn control machine operations such as spindle speed, tool selection, tool movements and cutting flow. So NC is nothing but the program is directly written on the scenes like NC machine, and it directly converts into output signal via machine control unit. So the processing equipment receives the signal and machines the workpiece. So by integrating a computer processor, computer numerical control or CNC as it is now known, allows machining programs to be edited and stored in a computer memory as well as permitting diagnostics and quality control functions during the actual machining. Now we can design the final piece via some designing software. So that designing software can give you automatically generate the codes we need. So this is a new advancement in the CNC machine. So what is the difference between NC and CNC? NC, you should write the program manually on a NC machine and you should run the program to movement of the machining process of the machine. Where in CNC you can write the codes in your computer and you can store it in a memory and it can be transferred to that CNC machine later, and it will generate output signal so that the machining process takes place. All CNC machining begins with the part program, so which is a sequential instructions or pulled commands that direct the specific machine functions. The part program may be manually generated or more commonly generated by computer-aided part programming systems. Basic CNC principle. All computer controlled machines are able to accurately and repeatedly control motion in various directions. Each of these directions of motion is called an axis. Depending on the machine type, there are commonly 2 to 5 axes. Additionally, a CNC axis may be either a linear axis in which the movement is in a straight line. So this can be represented by this picture where the tool moves in a straight line either in 3 directions, which is one of these 3 directions, or the drilling center. The drill tool will rotate, so that is known as a rotary axis with motion following a circular path. So basic CNC coordinate system. So it can be of two types: absolute dimensions and incremental dimensions. In these point 1, point 2, point 3 dimensions are the data driven from the point of origin. So if I give the dimension of point 1, it will say how far it is from the origin. So incremental dimension system, so the point 1 dimension consists of the distance from origin, and the point 2 dimension input consists of information from how far it is from the point 1, or how the movement is from point 1. So these are the two coordinate system in a CNC machine. So now we are coming to the topic CNC lathe. So what is a CNC lathe? Automated version of a manual lathe programmed to change tools automatically, used for turning and boring both metal and plastic. How CNC lathe works? It can be controlled via G and M codes. These are number values and coordinates. Each number or code is assigned to a particular operation that is typed in manually to a CAD CAM by machine operators, or GRM codes are automatically generated by computer software. So this is said, as I said before. So this picture represents the CNC lathe. The estimated price is 8,75,000. So this picture represents the technical specifications of a CNC lathe machine. In future, if you are working in industry and if you need to buy a CNC lathe machine, you want to go through this specification and you need to analyze what the kind of specs you need for your specific job working, and you should select a CNC lathe machine in the market as you need. So what are the advantages and disadvantages of a CNC machine? Advantages: it has high repeatability and precision. For example, manufacturing aircraft parts, you need this. Volume of production is very high. Complex contrast of surfaces, it can be machined via CNC lathe. Flexibility in job change, also automatic tool setting and less scrap. More safe and higher productivity, better quality, less paperwork, faster prototype production, reduction in lead times. So what are the disadvantages? It has a costly setup. Also we need a skilled operators. Computers and programming knowledge is required to write a program. Also the maintenance is difficult for a CNC lathe machine. Features of a CNC lathe machine. The tool or material moves. Tools can operate in 1 to 5 axes. Large machines have a machine control unit which manages operations. Movement is controlled by motors. Feedback is provided by sensors. Tool magazines are used to change tools automatically. So this brings a revolutionary change in a conventional lathe machines to a CNC lathe machine today. So where the accuracy, precision, protection of the workpiece, like protection rate, just drastically increased. So tools of a CNC lathe. These are made. These most of the tools are made from high-speed steel. Tools are designed to direct waste away from the material. Some tools need coolant such as oil to protect the tool and water. Tool paths, cutting and plotting motions. So tool path describe the route the cutting tool takes, where motion can be described as a point to point or straight cutting or contouring. Speeds are the rate at which the tool operates. Example like revolution per minute. Feeds are the rate at which the cutting tool and workpiece move in relation to each other. Feeds and speeds are determined by cutting depth, material, quality of finish needed, For example, harder materials need slower feeds and speeds. Roughing cuts remove larger amount of material than finishing cuts. Rapid traversing allows the tool or workpiece to move rapidly when no machining takes place. So the faster speed gives a rough cut, the slower speed feed gives a smooth finish, was what they're saying through these points. So CNC program basics. So in a CNC machine, the basic need you want to know CNC program basics. So when you know you only know to write a code, then only you can use the CNC Lathe machine. CNC instructions are called part program commands. When running, a part program is interpreted one command line at a time until all lines completed. Commands, which are also referred to blocks, are made up of words which each begin with a letter address and end with a numerical value. What is a letter address? It's going to be seen in next slide. So CNC programming, before entering or before giving the CNC program, you should know the coordinate system for your workpiece, units and incremental or an absolute positioning, also the coordinates, feed rate and spindle speed, coolant on or off, tool control should be known for the particular machining for the specific job you needed. So programming consists of a series of instructions in form of letter codes. Let's start with the letter address and its numerical value. The letter address G codes initial, that is said to be initial machining setup and establishing operations conditions. End codes specific program line under and executed by the MCU. Axis codes X, Y, Z used to specify motion of the slide along X, Y, Z direction. Feed and speed codes like specify feed and spindle speed. Tool codes to specify the tool number and miscellaneous codes like M codes for the coolant control and other activities. Programming key letters. So these are the different types of programming key letters used for program identification, line identification, axis designation, radius designation, spindle speed designation, tool length offset designation, tool radius offset designation, tool designation and miscellaneous functions. So CAD or CAM. Two computer-based systems which impact the use of CNC technology are computer-aided design or computer-aided manufacturing. A CAD system uses computers to graphically create product designs and models. These designs can be reviewed, revised, and refined for optimum end use and application. Once finalized, the CAD design is then exported to a computer-aided manufacturing or CAM system. CAM system assists in all phases of manufacturing a product, including the process planning, production planning, machining, scheduling, managing, and quality control.